So the Mineralogy Extension Task Group is co-convened by myself and Rachel Walcott from the National Museum of Scotland. I'm at Yale University. This is our task group. You can read the names: Thomas Burry, Alison Dombrowski, Nikolai Graber, Ollie Hintz, Adam Mansur's here, Andre Pushting's here too, Jolyon Ralph and Steve Richards and Chris Tacker and Malte Judge, I think. So it's a great group. We've been meeting for, I think, 2.5 years to put this together. Most of us were new to Darwin Core when we started. So a lot of it was just sort of introductory to data standards. And one of the goals that we've had since the beginning is bringing the geoscience community into TADWIG more. We know we've got a really great base of paleontology experts, but we really need to bring in, things of astromaterials and petrology and these sort of areas. So as we've gone along, that's always sort of underwritten all of our activities. And as such, during this process, we did a community review of just earth sciences professionals to review the vocabularies. It's a little out of order. Typically with TADWIG standards, you put together a vocabulary. You have an expert review, which goes on for about 6 months. So a couple of experts come in, they really get down into the weeds of the standard. And then it goes through a public review, which is usually open to all the public for at least 30 days. And then it moves on to ratification. We decided that as part of building bridges to the earth sciences community, we want to bring people in early into the process. We also realize that a lot of the TADWIG community inversely has a great knowledge base of biology and paleontology, but not necessarily mineralogy. So when we bring it to the TADWIG community, we want to be in a stronger position. We want to make sure that not only are all of us in agreement, but we have some of the earth sciences community already on board. And we know that'll help out the ratification process be smoother. And it was really good. These are all the people that participated. They went through different levels of these, but Alison Dombrowski actually joined the group afterwards, which was great at North Carolina. But all these folks did a review. David Fittmuller did a bit of a technical comparison with EFG. A lot of the other ones just went through the terms and then compared it to their own data. We learned a lot as well. We learned a lot that a lot of institutions now either don't have very much support from their collection management system, and a lot of their data are just in big remarks fields, which is natural. We think there's not a lot of, if you're trying to adopt a biology system for your geology collection, there's probably not a very good home for a lot of your atomized fields. And as such, they become into sort of comments fields. So we learned a lot along the way to this process too. As a side note, at this year's TADWIG conference, I submitted a proposal for a symposium focused on earth sciences data. And so the abstract submission deadline is now to the 26th. It is still open. We're happy to entertain all abstracts that have to deal with earth sciences data. I know we've got a couple lined up already, including Geospecify has agreed to sort of present on their extension. And I know I'll do one on a big geology collections data model paper, but we're open. There will also be a digitization workshop as well that I'm also doing. That'll be more how to get your data into the mineralogy extension and into sort of this compound model thing I'll talk about in a bit. And that'll be a separate workshop in addition to the symposium. So the mineralogy extension, traditionally, TADWIG Darwin Core extensions are in a one-to-many relationship with a Darwin Core record, meaning that you have one occurrence record and that specimen might have 5 pictures. So you've got one occurrence record and 5 pictures of one-to-many. That's traditionally how they've worked out. They're sort of encapsulated sets of terms that are connected to a Darwin Core archive record. The mineralogy extension is a little bit different. We took the word extension and kind of ran with it a little bit more than previous things. So we have a combination of things. We have new Darwin Core terms that are being proposed. We have the more classic extension, which has to deal with the compound specimen model. We have one new term for an existing extension, the chronometric age. We have these supporting vocabularies as part of mineralogy extension. We decided, well, we have all these vocabularies. Let's post those as well as recommendations. So we have these also value domains to not avoid confusion, but just sets of values that we can recommend as being part of our terms. And I'll show this in just a bit. And then we have these new things called material assertions. There are 17 terms in the mineralogy extension that are physical properties, such as inclusions, color, luster, cleavage. They're very important for mineralogy, but on the grand scheme of all Darwin Core, it's pretty small. Not a lot of data is going to come in that's going to have habit and cleavage, right? So what we decided was, and with Darwin Core DP has this new thing called assertions, and Darwin Core Archive has measurement or fact as well. What we decided was let's not propose 17 new terms for this little slice of mineralogy that don't have much applicability elsewhere. What if we could put them into a vocabulary that you can reuse, but not necessarily have that many more Darwin core terms? There's already quite a few. Let's not add to that. And so that's where material assertions come in. It's basically an extended vocabulary for properties for mineralogy. So we have these little set for this stuff too. We've decided that with the new Darwin core review cycle, which is quarterly, I think it's going to be, what's a bit of a flux at the moment, we're going to introduce our terms in phases. So we have a set of terms that we introduced this cycle, which is almost to its conclusion. We'll have a set more the next cycle and then a set more the next cycle. By the end of the year, we should all of them in. Part of the reason is a lot of them are low-hanging fruits to say. We know they have more broader applicability. We want to get those in and then sort of do this phased. And since we have this multi-tier approach, we think the phased approach is more suitable for that. The much more focused on mineralogy are coming in the next one. A lot of the ones that we had, hazard type. Hazard type also applies to botany, is more globally applicable. Name place is another one. The next round of terms will be much more focused on geology. And so we have a feature implementation report, and we have a bunch of other sort of supporting documentation to go forward with those particular terms. And then we have our vocabularies too. If you need, this is the chronometric age extension. This is more of a traditional extension for Darwin core. You have a bunch of terms, and they form a one-to-many relationship with a Darwin core occurrence record. Here you might have multiple ages with a particular specimen. So that's how the traditional ones have worked. Ours is a little bit different. So let's go back to presentation. Here we go. So we have our draft terms documents. In fact, just during these work sessions, we learned that we have a term called treatments, which we really like a lot. However, the sensitive species task group came along and said, hey, we've got 8 terms that are fundamental to our vocabulary that use the word treatments. So we need to go back and rethink this through a little bit about what you do in this scenario, because we're both pretty close. They prefix a lot of their terms with the word treatment, but if we introduce treatments, we don't want any confusion. And so we need to go back and sort of look at some of these things. But this is our latest draft set of terms. This is not meant for production. I still have a few changes that need to be made, but this is where they are on the mineralogy documentation page. And you can go here, and it's got the normative term list. This is generally where we're referring people to look. Oh, there's our GitHub. And it is, oops, keep clicking the wrong thing here. So it's going to work. There might be some bugs in the system. So here's a quick reference guide. So pretty straightforward. A couple classes. This structure, a lot like from Darwin core bag of terms. You have classes with properties. Conservation has 3 terms: treatments, handling requirements, damage remarks. Pretty standard sort of stuff. You will find that location is already a class in Darwin core. That's fine. These are 3 new terms for Darwin core records. So we reuse those existing classes to indicate where we're proposing they be added to. Name place, which is really important. Geology is type locality, these sorts of things. So, and then name. Proposal tracker. So we have our terms as they get proposed. I put them in the table here. And then as their status moves along, we'll just keep tracking them in here. And then our draft specification. So I wrote a fairly extensive specification guide to what the mineralogy extension records are. We realize we set the bar a bit higher with the mineralogy extension because it's so new to TADWIG and biology community. So we do have pretty extensive documentation, these sorts of things about how this thing should work. Which is fine. You know, a lot of it is, the question I get asked a lot, is this something I'm saying or is this something the community is saying, which is a fair question. So we have documentation to sort of explain this wider concepts and ideas that may be foreign to a lot of the community. And so we have this fairly extensive specification guide that talks about parts. And there's the compound model is something that is fundamental to most specimens in geosciences collection. It's new. It's in biology. Things like barnacles on a sea turtle. They're 2 species unified by physical attachment. They can be separated, but they're usually not. Most specimens in a mineralogy collection, geology collection are compound specimens. They have unified things in multiple parts. And so that concept, although there is a few things, algae and things like this in biology have the same thing, but it's an overwhelming majority of things in the geology collection and fundamental to the mineralogy extension. So there's some documentation that explains how that works. I won't get into it here. This is another example of it. This is, where was it? I had this here. So you can see scheelite is this mineral here, these nice little pyramids here. But this gold is dolomite, and they sit on top of quartz. So these relationships are really important. This is 3 minerals. Typically in a collection, you will find it just listed as scheelite, but then that ignores the dolomite and quartz. And so what we're trying to do is bring that in and more proper handling of these multiple things. And they also have relationships, right? The scheelite sitting on top of the quartz, and that relationship is very important. And so within the mineralogy extension, you'll find things to characterize these things in an atomized way where you can really start describing what they are. Same thing with this guy. This is a pseudomorph. This is malachite, the green. The blue is azurite. This is malachite after azurite. So that literally the azurite's turning into malachite. Right? And so that relationship is very important as we go along. So Darwin Core now, with the new release, does support the compound model. It will have a term called is part of material entity ID. There's still some things to go, but this is really, really important because this is the first part of supporting this model. You have one specimen here, let's say material entity ID 1, and then you have 2 parts here, and they both have a self joined to the 1. So these part 2 and 3 is a mineral almandine and has the self joined 1 to 1. So you can create the compound specimen model, which is really good. And this is coming out very, very soon. And this is part of Darwin Core DP and part of Darwin Core Archives. You'll be able to make these specimens in both. Darwin Core DP is a lot more suitable for a compound specimen model, but Darwin Core Archives will work as well. Any questions before I go on? Questions in mind? Wouter?
Yeah, Ben, I think sampling of geosamples usually does that in specific sites that have an area and a name. Is that how would you support that in the mineralogy extension?
It's a great question. So we have a term called sampled feature. And that is, typically you have these massive, one of the big differences are you have this big rock body in nature, tons of square miles, big rock body. And in a geology collection, you're knocking, and I have one. Here it is. This is Martin limestone, Martin Formation, Southern Arizona. This is one piece of a much bigger body in nature. And so what we have is a compositional lineage between this and a body in nature. And that relationship is really important because it's representative of that, in theory, representative of that feature. And so we have sampled feature for that. There are 2 components to that. There's the lithologic one. There's also, was it an outcrop? Was it a vein? Was it a mine dump? How did you acquire that from that particular source body in nature, making that connection between the 2? And so we have a term sampled feature that's adopted from a couple other vocabularies for our own purposes. That's here. Any other questions? And then as time went along, I built over the summer with help from the travel fund from Tadwig, I built a application. And this is geospecimens.org, although it's just ignore the URL still is GeoAPIs because it takes a lot to transfer a domain name, and I just haven't done it yet. But it all redirects. So there's a lot of tools in here. I won't get into too much. You can search timescales. I think there are 40 different timescales on here. I'll have a link in the chat. You can see here. You can see all these timescales. There's a bunch of interactives about classifications. You can search mineral names. I know I'm going through this relatively fast. You can also search Tadwig standards. So if I collections here, I get back all the terms with collection in them. And this needs to get migrated over to a Tadwig site, but beside the point. So it has an API where you can do an API request for names classification, geologic timescales. It also has a backend where people actually enter data because we figured if we need to prove that this thing works, it's more than just writing down somebody did it. I figured that what would really prove it is if somebody went in, they had the mineralogy extension terms, and they actually entered data using it. And that's exactly what this application does. So, and we have maybe 25 or 30 specimens that have gone in and actually entered their data into the system, and it worked. we did also make some changes in response to it, which is nice, right? We had a mode of occurrence term that we dropped because it didn't make sense once we started entering data. It was an overlap with a different term, and we decided it just wasn't necessary. So we dropped that one. And so this is all in a feature implementation report, but this is what it is. So even as mids, which is cool, mid shows up. But people actually went and actually entered data into this. So if you're going to prove it, I don't know if there's a better way to prove something works. Somebody actually enters data into it. Here's a specimen. So it has all the core metadata here. Location. And Adam actually entered one of his, which is, thank you, Adam. Adam, you want to say anything about the application at all?
Just that if there's a way to pipe data in, we'd be able to add more, or some sort of backend load process. But we've sort of gone as far as we can with, manually duplicating records that already exist in other systems.
It is a duplication issue. That's true.
It's not so much that, it's just like the ability to, upload data in bulk would be useful, but we can't manually type in everything.
Yeah. So my personal collection isn't digitized at all, really. So I I had an extra incentive to put my stuff in some of my things, but it worked, right? I mean, you have everybody in their data, right?
Yeah.
Cool. And it also ties in the vocabularies we had too. So, and I'll show that too. We have this site just launched last week. I finally got it off the ground. And so there are control vocabularies, aggregate form, proportion, material type, which actually, John, I'm going to change the category, I think, which is nice about this application. Here's the thing. This is experimental and draft. I do make changes. If it says experimental, it's supposed to be, and I probably should make this much more explicit, but experimental not to be used in production environment yet. There is a term material type that needs to change, material category, because just for a lot of reasons that are outside the scope of this. But hazard types, and then we have 6 terms. And we did this as a group as well. We had vocabularies we put together, people reviewed them, we came together with a consensus and then published them. And I think we have 5 more to go. And these are fully resolvable with URIs. Here, you could do RDF, Turtle, all that kind of stuff. All those requests work. They should. There's also glossaries, a collection digitization glossary I wrote for a different project. And there's an API where you can test out the different serializations and then ignore it. It's still a draft thing. In fact, I changed the URL last week too. I'm still changing things as I go along. So, but that's moving along. So it's good. It's going to get used. There's a new Swiss Geo data portal that's coming out that's going to leverage it. Pollux, my day job at Yale for the Lux platform, is going to start using it for concepts that aren't in Getty. We're going to have to post them somewhere. And so it should work out. So it's used for different projects and things. So anybody have any questions? Wouter, yes.
Sorry, I keep asking questions.
Go for it, man.
Because this is so interesting.
Right.
As you know, in this call, we distinguished between specimen and specimen parts, and there are a couple of reasons for that. One is that there are some properties for a specimen that are not there for a specimen part, like catalog number.
Yes.
They share a lot of properties in common, like the same collection event and same collector, etc.
Sure.
But we also thought that people would, if they want to reference a specimen, they want to reference the specimen as a whole and not the specimen part.
Right.
So we give the specimen part an identifier, but it's just a handle. It's not a DOI. It's not meant to be referenced by people. What do you think about that? Do you think that people would like to reference directly to a specimen part, or just to the specimen as a whole?
I'm going to find a presentation where I talk about this. Give me 1 second. Here we go. So this one, no, it's not this one. Doesn't matter. So yes and no. So I think there's 2 parts of this. There is a process by which everybody's data currently is in the simple specimen model just because of existing biological system collection management systems that are not split into parts but need to be. And everybody wants this thing. So there's a process just getting it to a parts model, right? There's a time link there. I think generally there are some use cases where if you have an almandine schist, big almandines with a schist. The almandine is the thing that got dated, and that was then interpreted as the timing of the metamorphic event. So in a sense, that extended specimen relationship needs to be on the almandine. Now, whether you have to use the DOI to do that is another question, right? But there is an important distinction there because sometimes analyses really does matter which thing it was done on, right? Instead of just giving a date to the whole object. And that's where there's a lot of instances like that where analysis is done on a certain part that's then drawn into interpretations of other things. And it's important that we don't put the relationship on the entire object on the individual parts for that data, right? And so in that case, I can't see that happening. Now, whether it's a DOI, I'm not so sure either. If I can get to the DOI and then know it's that part, then I think that might work as well. But I think yet to be seen how to sort that out. Does that make sense?
Yeah, that's helpful.
Can I make a comment?
Please do.
Ben,
Rachel,
hi.
yes.
I can see another use case in which that would be useful, Wouter. And that is a classic problem in mineral collections where you may have more than one type specimen in an object, which is what we have at National Museum Scotland. So if you're wanting to refer to the type mineral, in our case, we have mathedolite and macphersonite in the same specimen, then having a unique identifier for that or other associated minerals could be useful in future.
Do you, in that case, give both a separate catalog number? So
we don't currently.
Okay.
No, we treat it as an object. Most museums treat the physical object as the SI unit, but that is a classic case where we're trying to fit a system that wasn't built for mineralogy to mineralogy.
We do the same with our types at the Smithsonian. So it'll be one object, potentially with multiple types of minerals on it. So that's very common.
Which is quite an issue, right? So there might be lists as common because a lot of times, at least people will put the most important thing as being the mineral, right? But then if you have type specimens, it's like, you sort of lose that context because you put them in comments or you can only say it's one, right? So it's usually the one that's organized into, but that doesn't really do justify when it's a type, right? That's a great example, guys. And then what's next? So once mineralogy is done, we do have more geology to go. The idea behind mineralogy first was that paleo and mineralogy, to borrow a term from geology, is a sort of an end member of the geo community. And there are things now in the middle. And so in a way, there's not minimal overlap with mineralogy that there is with biology and paleontology, right? If you're going to separate the two. And so the things in the middle are ores, and the top level things are organized into meteorites, ores, and rocks. And so whether those will be all knocked out in one particular extension is yet to be seen. But those are the top level categories. Minerals, rocks, meteorites, ores are generally the top level categories for collections within the earth sciences domain, the four major ones. Sometimes they mix them, sometimes they don't, but that's in general how they're broken down. Any other questions, comments?
What are you going to do about sediments? I'm thinking, so we don't have a lot of sediments. We don't have a lot of sedimentary rocks, but we do have a lot of volcaniclastic. So tephra, that kind of stuff.
Would you put it, so here's the vocabulary that I put together. Astromaterial material, which is sample return missions and direct products of impact events and meteorites, fossils, mineral, or rock, and then unconsolidated. Would you put that under unconsolidated? These types of things?
Yeah, I mean, you got to put it somewhere. It's not really a rock.
Right.
It's funny because then you end up splitting like your volcanic material in a funny way, but that's a problem that shows up in the rock classification schemes anyway.
The rock classifications are very challenging.
Yes.
Mineralogy has a couple, in case they're unfamiliar, that mineralogy generally has two major ones, Dana and Nicholstrons. And if you draw a line down the Atlantic Ocean, for whatever reason, we're still not sure why, but in the United States, it's overwhelmingly dominated by Dana, and Europe, it's Nicholstrons, and for historical purposes. The problem is that Dana was stopped being published in 1997, was the last one. There are 1,000 new minerals have come online since the last publication. But every mineral collection in the United States is physically organized according to Dana. So no one has the manpower, the resources to reorganize an entire collection So it persists. And a lot of times you can only have one in your collection management system anyways, because that's just how they, Linnaean taxonomy is generally one. Biology has one system, which is the Linnaean taxonomy system. So it's an interesting situation. So we're trying to map some of these things together and see what we can do to have both. And Darwin Core supports that too, for sure, which is really good. Because we need to start, the first step would be allowing people to say it's the Dana and the Nichols-Strunz, both classifications for a single thing. Once you get those together, then you can start making this sort of migratory path instead of just having to pick one. So. Any other questions, comments? I had a presentation on some other things. That specimen must be somewhere else. So. Rachel, you have anything? Any comments?
No.
Okay. That's all I've got today. We are pretty far along this process. So there's a hand raise. Yes.
Yeah, sorry to bother. I was wondering if you thought about drill cores and if they are like in the unconsolidated material that you just described, or they are like in another future extension to come, because I think they can definitely be in the unconsolidated. I don't remember the exact name, but the unconsolidated term that you mentioned, but I'm not sure.
So the way we thought about them is that drill cores are compound specimens to themselves, and they have multiple formations, right? So you might have a drill core with successive formations out of the ground, and actually it's one unit. There's some really nice rock core database online. Kentucky's got a really good one, and I've got some examples where it says this depth is this formation, this is this formation, this formation. So it's one compound specimen and 3 rocks in a way, because each one has a separate formation name. Member bend, things like this. It depends on how you want to divide it up, but you have flexibility to do that. That's how we kind of think about it.
Okay, thank you.
Makes sense. Anybody else? Well, stay tuned. I know the Darwin Core public review is about to get submitted to John, correct me if I'm wrong, but submitted to the executive committee for final approval. Once that's done, there'll be a series of terms that come out with Mineralogy Extension, and then the next one we'll just start rolling with them. And the next one is big for Mineralogy Extension. It's going to be much more of the in-depth terms, the feature report, these sorts of documentation that get put up for review. Is that right, John?
Yeah, we expect Steve to send the message for the executive to check our review later today. If Steve has time, I think he'll have time.
Okay. Sounds good. If you have questions about this stuff, you can email anybody on the task group and they'll be happy to answer questions. And this presentation and the recording will be on YouTube. We'll make sure that the presentation is linked too, because it has all the links to various resources you can check out. In fact, I just finished the feature report last night. And so there's several members of the group that are on this call. They didn't know I was done with it. And so I got to send it to them too. So, but they've heard me talk about these things 1,000 times. So anybody else?
Did you see the comments, Ben? I put in 2 that might be useful to have in the back of your mind. Yeah.
So treatments is a term under the conservation class. And so I'm not sure how to handle that, right? Because they've got treatment in the word. They don't use it by itself, but they do use it in a lot of their terms as sort of like a qualifier and something else like RS. I went through some of their stuff. And do you have any thoughts about that, about reusing words? I'm sure this has come up before.
So you mean in their definitions and comments, they would reduce the DwC:RASD treatment to the word under lowercase treatment. They shouldn't do that. And we as a maintenance group should not allow it because it's something very specific. So we redid all of Darwin Core to avoid that issue. When we mean occurrence or organism, we mean it in the way Darwin Core does. So it's a class, DwC:(OR) organism, because it's not the same in natural language. It might not be the same thing. So I think we should urge that, and that will avoid any issues.
So you don't think that for them using the word treatments and us using the word treatments, there's going to be any confusion there?
If you're explicit,
okay,
no.
Cool. Well, that's good.
I mean, it'd be sad if it's something embedded in the discipline and you have to avoid it because somebody else used it. It's just kind of silly.
We deliberated treatments for quite a while, and it's a term that because there really are things you do to minerals to protect them for whatever reason, right? Gloss,
Mhm.
and those are really important for analytical purposes and these sorts of things. And so we really settled on.
Otherwise, maybe you can negotiate with them and see if they'll call it consequences or something.
Yeah. They are protecting endangered species. And so if we get to it, protecting endangered species is going to beat out the mineralogy extension if we got into a back and forth, right? It's like, what are you going to do? So issue, and Darwin Core DP does support multiple types of, which is great. They're in a sense all you have. It's a bit odd to think about, but a compound specimen is a material, and then each part is a material. So they are basically material entities, which has its basis in the basic formal ontology, which talks about all of the existence of everything. It's actually a really cool ontology to read about. There's some really good books on it. But they are both materials, and so they all get housed as self-joined this materials table. And then you can have different types and extends out from there. And you can have, each material can have its own geologic context. That's not necessarily available in Darwin Core Archive, but is in Darwin Core DP because it's related, which is much more powerful in a way. I guess you can kind of do in Darwin Core Archive, but it gets...
Each part can also have its own material assertions.
Yes, which is really important. Yeah, because about, as you said, like they do share collecting event, location, these sorts of things, but there are, and we have a scope term in a lot of mineralogy to make that clear. So material scope, I'll share my screen. We wanted to make this clear on the mineralogy. So we actually have this thing called material scope, which talks about specimen or constituent part. And so what level, and I think there's maybe only one that I think the description was at both. And so what we did was we said, okay, well, we really want it to be either or. So there's a term called specimen description, a term called constituent part description, just to sort of split it, because we want to make sure that's kind of a rule that each term can be one or the other. And so we'll have that listed on our documentation. You can see handling requirements, treatments, these kinds of things are all based on parts, like the chemistry as a part level thing. These sorts of things. That's a yes.
You have a good idea of what would come out exactly in the next set of proposals?
To talk about the extension,
you said
parts,
that you expected to stage the proposals.
Right. So these were, part of it is I know some of the terms got introduced in Darwin Core DP in coincidence with mineralogy, like geoname, for example, right? Those we need to sort of filter out. Now the DP has been ratified, we can sort of say, hey, these are done. Because I don't want to make a proposal that has some sort of crossover with existing. It would be confusing. And so we need to go back and look at which terms have now been handled and where they are, right? Because we don't want to duplicate any efforts. That's one of them. And so whatever's left, then move those in. And there are a lot of, and also the material assertions is a big one too. How we're going to handle those, because we want them to go through it for review, but not necessarily full Darwin Core terms. So I'd already get with you at some point and talk about how to do that. There were a couple that went through verbatim mass and measured mass because of MIDS, because it's a requirement in MIDS 3. So those were a bit of an exception. But those things, those are the two main objectives for the next round and why we waited on some of those terms. Does that make sense?
I think so. To me, I have a preconceived notion of how that would go forward, but it's a mix of controlled vocabularies and properties.
Yeah. I think we should talk that out and then take it and have a meeting with the whole group and to sort of see how this stuff would work. So yeah, these are our material assertions here. Yeah. Anybody else? Wouter, your hand's still up.
Yeah, it's maybe more Darwin Core data package related question for John. If we were to generate a data package, would you expect that we populate all the properties in each material entities if you have a compound object? Or would you expect to have that only in the so-called parent material entity?
Right. I suspect that the situation is similar to what we found building the Humboldt extension for surveys, in that there's a whole document that describes why each event should have all of the information that's relevant to itself, and that there should absolutely be no inheritance, and some other aspects of that. So I suspect that this is a similar pattern, that informatics wise should probably follow the same suggestions. I can go get that document so that you can see what I'm talking about. It'll take me a minute here.
And now some of these will apply to the whole specimen, like the measured width and height and depth. These sorts of measurements are mass and things like that are definitely with the whole specimen. Some of these are not. So like max crystal dimensions, things like this, luminescence, luster, cleavage are really to the part, the individual mineral. And so, but the nice thing is too about Darwin Core DP, these material assertions, is that I think that not everybody is going to want to define a part for everything. If I have a single quartz, why would I make a part of that? And I think we're going to have to, there's enough flexibility to say, okay, you don't have to use this model. If you want to, you can, but you don't have to. Then there's the option of, okay, I want to use full-fledged model. I want to fully characterize the properties that go with individual parts and specimen. And we'll see how this sort of works out. I think that's important to apply both, especially as data comes in that it will be in a simple model as we sort of grow this. Because I'll have to have transformation procedures for certain clicks I'm working with to actually split their data up into parts, right? They won't have it inherent in their system. And so it'll be a slow process, but that gives them the advantage of doing that. And that's the nice about the self-join. If you had a split table into parts, if you had there's the model of having part, specimen part one to many, and then certain properties with the part. The problem with that model is that what if you just had the specimen? Then you couldn't use the parts unless you created one part that's 100%, which is doable, but a bit awkward. And so the other model would be to put them in both and have a self-join that it's all materials, right? So you can have a geologic context to the entire specimen or individual part, depending how the data provider wants to characterize their data. And so the bad side is that you'll have a lot of duplication in archives. Like you'll have the location will get duplicated for every part, right? That's the unfortunate part, unnecessary metadata, but that's okay. It's not the end of the world, right? It's just a bunch of unnecessary, duplicated content. But it allows people to make a transition as things move along to a part model.
I put the link in there.
Yes, thanks,
Wouter.
Yeah.
Ben, I'm not sure that duplication actually would happen, because
in an
at least
archive,
in a data archive. Okay, sorry.
Yeah.
Archive C. No,
Yeah,
but in a data package, no.
Yeah, absolutely.
Yeah, because it's relation.
Right.
Yeah.
I guess it would have to archive, but
yeah, Ben, for the assertions, we need to see how we going to handle this vocabulary in Disco, because currently it's kind of free text annotations that you can make, because any assertion is possible. So how to handle controlled vocabulary for part of it, I don't know yet. So we will need to look into that.
It's the tricky part, right? You want to give people flexibility of sort of custom properties, but you also want to control it. It's like I did this is like 8 years ago, but we had to do iNaturalist photos of red fox, and I built the application as you filter. And we realized that when you search for red fox, you also get red fox scat. We didn't want scat. And then we looked at the custom vocabularies, and there was 20 different ways to write scat. So it's like we couldn't filter these things out. And so it's just but if you give it to people, in a sense, an easy way to ingest in their system, they'll want to use it, because I think people understand why controlling those terms is worthy. I mean, for sure, you have to make it easy for them to integrate it and to utilize it. So that's the trick to it. Steve, you want to ask in chat? I think I understand. I think I follow you.
So yeah, I mean, basically the standard thing when you have these all these different kinds of relations is to try to have a controlled vocabulary for high level relations, and then the specific relations that people want to assert under those in free text. So you're probably doing that already, aren't you? Ben, I don't know. Anyway, that's just what I was commenting on. But yeah, so the focus here is on defining individual specimens, I think. Am I getting that correctly?
Yes. This is
Okay.
Yeah.
And so the broader context would be you're describing a geologic unit in a regional geologic map context where you want to describe the rocks that are in that unit. That's a different kind of use case.
This is very collection focused. In fact,
yeah,
this vocabulary here, really, a meteorite is a rock, technically, right? I mean, that's really, you know what I mean?
Right.
But because an ore is another, an ore is just kind of a qualifier because it's like if it's an economic interest, so it's not really but in collections,
ore has connotations that have nothing to do with mineralogy
at all, right? But in collections, these are the major categories of collections, right? This is how they're split up. So this is sort of the decision-making process into this, why the word specimen is here, because the decision-making process is really focused on the collections themselves.
Mm-hmm.
You can argue that astral material is separate because you can say it's space or whatever, but really, compositionally, it's a rock. But an ore is a complicated one. So
fossil as well.
Yeah. Well, that's I know. Right. So some of these are good, but in collections, you're always going to have these divisions, right? So, and rock core did fall under here, but unconsolidated. So that's a lot of the focus here, and then a lot of focus for the standard too, really on collection specimens and the needs of those things. John?
If we have time and interest, can we do a quick look at material assertion from the data package? Because I'm curious what Wouter's thinking in terms of challenges and how the challenges differ between a Darwin Core archive and Darwin Core data package. So I put a link in there. Oh, no, I didn't.
John, you want to share your screen? You want to just leave it?
Here. I can do that.
Okay. Yeah.
Sorry, that was local.
Your co-host, no.
I think that's what I wanted to show. You seeing my page?
I do.
Okay, so this is a quick reference guide view to what a material assertion looks like, and in a Darwin Core data package. So there's a material entity ID at the front of it that says what it refers to, and then a whole bunch of measurement and fact type terms. They're called assertions here. Don't need to get into why that is, but the point is that there are both free text and IRI versions of values that the thing can have, and sources that those values can come from, and the interesting thing to me here is the assertion type. So the assertion type would be, to me, a way to declare the controlled vocabulary from which the value comes. So if you created a min-ext material entity, no, which ones were we talking about here? The material assertions?
I've got one for you. 1 second.
What did you call them?
Here's one. Aggregate form is one.
Aggregate form.
And the value list is here. There's the term and there are the values.
We're going to see my chat while I'm doing this. So the idea would be your assertion type says where to find the vocabulary, or sorry, what the category of control vocabulary it is. And your values would come from that vocabulary. And you can do any mix of values as free text or IRIs. And you can also do the same for where that vocabulary is specified. So if there's an IRI to the vocabulary itself, you can give that. Or if not, you could give a web page or a reference in a book, whatever, in order to say where you can figure out what the value means. So if you were to do that, this leaves it open-ended. It leaves it to the controlled vocabulary constructors to define formally or otherwise what you're actually sharing, as opposed to having the problem of defining actual properties for each of the different types and having, basically a table get very wide and only contain those things that have been decided to go into a schema, which is, not a very scalable solution. So if it were like this, if you did it this way, would that present particular challenges on the DISCO and digital specimen side?
I think not for the storage parts. I think maybe for the graphical user interface part. So how to do that in an easy way for people to add new assertions. And yeah.
Or reuse existing ones, right? Trying to use
Yeah.
how to deliver people those vocabularies in a quick,
Yeah.
easy, concise way. Yeah.
Anyway, I thought that might be,
Schema-wise, I think this is good.
yeah, it's scalable.
Yeah.
Steve, I think Steve has a question. Steve?
Oh, I was just, looking at this, I think kind of overlaps with this idea of conformance classes, right? So you're describing a type, which is a collection of properties that you might associate with some kind of instance. And on the one hand, you can be describing types. So I generally come from thinking about describing geologic units on geologic maps, where you're saying, okay, well, this material has these kinds of material properties, right? The materials that are in them, the relationships between the materials, things like that, as opposed to describing an instance, which is a particular rock you're looking at, right? Which has these specific minerals in these specific kind of forms. And is the type you're talking about, okay, how do we describe an instance? How do we describe a property? This is something we tried to capture in GeoSciML with a description. There was a description type, to control vocabulary. Is it an instance? Is it a type? I don't know if you're thinking about that, but that's what I was thinking about. So
I think here are the instances, right? John, do you got anything?
Yeah, with an assertion, you're definitely making an assertion about an instance. But I was kind of stuck on something previous, and I don't know if I'm misinterpreting what you said or not, but the formations themselves are material entities. Does that help or hinder anything?
but within the context of a formation level thing, then your description has to say there are ranges of values, typically. And there are these kinds of things that might be in the formation, and these are the necessary descriptive values, and these are the required description values. Whereas with an instance, you're saying, here's what I've got. These are the specific things about that instance. But again, I think in a lot of the collection stuff you're talking about, you're dealing mostly with instances, right? You have a particular rock and you're describing that particular rock. Whereas with in a context of thinking about describing geologic data sets, you're more dealing with, okay, here's, this formation is a type. here's the things, here's the necessary conditions, here are the required conditions kind of things. There are different kinds of descriptions.
I
But
guess where I get
think getting
stuck
out of
is that,
scope here, sorry.
but it's super interesting to me from a modeling perspective because I don't see that there's anything missing in the model that would allow you to do it either way. It's kind of you as the data custodian decide how you want to represent things. So you can have the instances in your collection and have them refer to materials that are not in your collection. You know, beds and formations and things out there in the real world about which you assert different things. You know, whether they
Right.
be summary or individual. You can talk about parts of those formations as well as material.
Right.
That's not usually what you do in your collection, but somebody does that, and they could.
Right. Yeah, but coming out from the point of view of describing a geologic data set, I mean, typically you have to say, you know, okay, here's the criteria for why this formation is unique. And sometimes it's material, sometimes it's relationships. So but it's a different, I think it's a different use case. And sorry, I think I'm getting out of scope here.
I've tried to make that clear to in my paper, Steve, because now you commented on that. I've geologic collection data model paper coming out, and that's a really important distinction about the bigger formations and the things within a collection, which are really, I think the types and instances are really good. You know, like this particular limestone has fossils in it, but the entire formation doesn't have fossils, right? There's some parts of it that are fossilless, right? And so if you're going to chart the whole thing, you have to do both. But for a hand specimen, you really just say, you know, it's got these fossils in it because it's an instance of that bigger
And what
body.
makes it this formation is these guide fossils, or its relationship with other things.
Yeah.
Anyway, sorry.
No, it's good. Thanks, Steve. A lot of these things are built on Steve's work, just as a side note. None of this would be possible without his work. So I appreciate his time.
You have a good idea how you will decide on the approach to dealing with material assertions?
So
one way is to say, okay, here's a solution, here's another. Which do you like?
I know.
Another is to have a bunch of meetings and discuss back and forth.
There needs to be, so we've settled on these properties, and there needs to be a way where people can use them very easily. Because if I've got things in my database that I've got type, I think we say twinning law, and twinning is probably written 15 different ways, if more than that, in people's databases. So how do you get from that, even in individual collection databases, to a standard vocabulary? It's going to be a trick. And so I've not quite figured out how to get, there's the existing data, sort of uniforming it, and then there's the going forward kind of implementation thing, right? But if you use these, hey, these have been agreed on. If you want to reference it, this is the one people are using. I think that's an easy sell for people. Getting their data into this is a different story, right? And so, but I've yet to sort of figure out, first of all, is it actually atomized in the first place? It's a whole nother question. But that have not quite worked out yet, how to easily get it to people. I think it's going to be a use case on the ground with people saying, you know, we'd like to use this. We know you'd want to use it. How do we make it easy, right? And then I imagine we're not the only ones, right? So I imagine there are really people in DwC-DP that have these assertion, at least maybe not right now. Our timing was just really good, but thinking about these, you know, assertion vocabularies.
Yeah, there are plenty of instances where they're needed. Or desired. I don't know about needed. That's a different level that I don't want to judge.
Thanks, Wouter. Well, that's all. I think we're about by the top of the hour. So thanks everybody for coming. There'll be more in the repo and more on the draft documentation page as things move along. And there's a paper coming out soon when I get it. There's several people on this call that submitted comments, several. I am desperately trying to reconcile everybody's comments to this. It's a 60-page paper at the moment too, which is a bit long for this. But we will, it's soon. It's coming. And so
And another meeting later
unfortunately.
today.
So we'll see how this all goes. So thanks, everybody. Shut the recording here.